Hello, in this lecture we will find out the value of angle x using two different methods. In the drawing we have triangle PQR. We know that QS is equal to SR. We also know that angle PSQ equals to 45 degrees, angle PQR equals to 3x, and angle PRQ equals to x, and we want to find out the value of angle x. So we will start with the first method. In the first method we will define angle QPS as alpha, and we will define angle SPR, this angle is beta. What is the value of this angle? We will define it as y, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line QR, we know that the sum of the angles must be equal to 180 degrees. So if we focus on the upper side of the straight line QR at point S, then we know that 45 degrees plus the size of angle Y must be equal to 180 degrees. That is to say 45 degrees plus the size of angle Y equals to 180 degrees. We will subtract 45 degrees from this equation, and we will get that angle Y equals to 180 degrees minus 45 degrees. That is to say angle Y equals to 135 degrees. So we found out that angle Y equals to 135 degrees, so we can substitute angle Y by angle of 135 degrees. In the next step, I will present to you a new rule, or actually it is the law of sines. The law of sines is true in any triangle. So the law of sines in any triangle if we have this triangle and we know that the size of the length of this side is A units, and the angle that is located on the opposite side of this side is angle A, and we also know that the length of this side of the triangle is B units, and the angle that is located in the opposite sides of this side is B, and we also know that the length of this side is C, and the angle that is located in the opposite side of this side is C. So according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. I'll repeat again, according to the law of sines, in this triangle, A over sine A equals to B over sine B equals to C over sine C, when A, B, and C are the lengths of the sides of this triangle, and capital A, capital B, and capital C are the angles, or the interior angles of of this triangle. From this formula, we can derive that A over sine A equals to B over sine B we will multiply this equation by sine A, and then we will divide it by B, and we will get that A over B equals to sine A over sine B. Okay, so what is the meaning of this equation? The meaning of this equation is that the ratio between the side lengths of any triangle, the ratio between the side lengths of any triangle equals to the ratio between the opposite angles. I'll repeat again. From this formula, we can conclude that the ratio between the side lengths of any triangle is equal to the ratio between the opposite angles. Okay? So, in our drawing, we can create the equation that states in triangle PQS, PS over QS is equal to PS over SR. I'll repeat again. In our drawing, PS over QS equals to PS over SR, and why this equation is true, because of the fact that QS equals to SR according to what is given us in the question. QS equals to SR, according to what is given as the question. But according to the rule that we derived from the law of sines, we can say that the ratio between the sides of triangle PQS, that is actually PS over QS, equals to the ratio between the opposite angles. That is to say, it equals to sinus 3x over sinus alpha. So PS over QS equals to sinus 3x over sinus alpha, and PS over SR in triangle PSR, PS over SR in triangle PSR will be equal to sine X over sine beta. Okay. And we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, in triangle PQS, we know that the sum of the angles in triangle PQS is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. I will repeat again. In triangle PQS, the sum of the angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. Here we will subtract from this equation number 2, 3ax and also 45 degrees, and we will get that angle alpha equals to, according to equation number 2, angle alpha equals to 180 degrees minus 3x plus 45 degrees. Okay, so we actually found out the value of angle alpha in terms of x. Likewise, in triangle PSR, we know that the sum of the angles is equal to 180 degrees. That is to say, beta plus 135 degrees plus angle x must be equal to 180 degrees. I will repeat again. In triangle PSR, the sum of the angles is equal to 180 degrees. That is to say, beta plus 135 degrees plus x equals to 180 degrees. Here we will subtract 135 degrees and also x from this equation number 1, and we will get that angle beta according to equation number 2 is equal to 180 degrees minus 125 degrees is 45 degrees minus x. So we found out that according to equation number 2, angle beta equals to 45 degrees minus x. And now we can substitute alpha and beta in this equation number 1 by the values that we found for alpha and beta in equation number 2 and equation number 3. Okay, so we'll do it now. We will get that according to equation number 1, sinus 3x over sine alpha, and according to equation number 2, alpha equals to 180 degrees minus 3x plus 45 degrees, and it equals to sine x over sine beta, and according to equation number 3, beta equals to 45 degrees minus x, we have the trigonometric identity that states that sine 180 degrees minus theta equals to sine theta. So according to this trigonometric identity, we will get that sine 180 degrees minus 3x plus 45 degrees equals to sine 3x plus 45 degrees so we'll copy equation number 1 after we change this expression, and we will get that according to equation number 1, sine 3x over sine 3x plus 45 degrees equals to sine x over sine 45 degrees minus x. Okay, so here we will cross multiply this equation number 1, and we will get that sine 3x times sine 45 degrees minus x equals to sine x times sine 3x plus 45 degrees here we will multiply this equation number 1 by 2, and we will get that two times sine 3x times sine 45 degrees minus x equals to 2 times sine x times sine 3x minus 45 degrees. Here we will use the trigonometric identity that sine 2a times sine b equals to cosine a minus b minus cosine a plus b. So I write down the trigonometric identity that 2 sine a sine b equals to cosine a minus b minus cosine a plus b. We will use this trigonometric identity in order to simplify our equation number 1. Here, in our specific equation, in this side of equation number 1, we will get that a equals to 3x, b equals to 45 degrees minus x, so 2 sine 3x sine 45 degrees minus x, according to this trigonometric identity, will be equal to cosine a minus b. A is 3x, b is 45 degrees minus x, so we will get it equals to a minus b is 3x minus minus x is 4x, and 0 minus 45 degrees is minus 45 degrees minus cosine a plus b. A plus b, when a is 3x and b is 45 degrees minus x, is 3x plus minus x is 3x minus x. That is to say, it equals to 2x. And we have also 0 plus 45 degrees is 45 degrees. So we finished with this side of equation, with the left side of equation number 1. We will continue with the right side of equation number 1. Here a equals to 3x, and b equals to 3x minus 45 degrees, so it is actually equals to cosine a minus b. So it is cosine a is 3x and b is 3x minus 45 degrees. So x, a is x, and b is 3x minus 45 degrees. So it is x minus 3x is minus 2x, and 0 minus 45 degrees, it is actually minus 45 degrees. So it is minus 45 degrees. But we have the trigonometric identity that states that cosine minus x equals to cosine x, so we can substitute cosine minus 2x plus 45 degrees to cosine 2x plus 45 degrees. We will change the negative sign to positive sign according to the trigonometric identity that cosine minus x equals to cosine x. And then we have also minus cosine a plus b. Minus cosine a is x and b is 3x minus 45 degrees. So it is a plus b, yes? So it is x plus 3x is 4x, and zero minus 45 degrees is minus 45 degrees. So, in conclusion, we got that according to equation number 1, cosine 4x minus 45 degrees we will add to this equation number 1, cosine 4x plus 45 degrees and we will add to this equation cosine 2x plus 45 degrees. So cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees, it equals to 2 cosine 2x plus 45 degrees. So actually cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees is similar to the trigonometric identity that states that cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. And for the expression 2 cosine 2x plus 45 degrees, we will use the trigonometric identity that states that cosine A plus B equals to cosine A cosine B minus sine A sine B. So we will get that here C equals to 4x minus 45 degrees and D equals to 4x plus 45 degrees. So cosine C plus cosine D equals to 2 cosine C plus D over 2 equals to 2 cosine C plus D is 4x plus 4x over 2 is 4x, and minus 45 degrees plus 45 degrees is 0. So it is 2 cosine C plus D over 2 times cosine C minus D over 2. C minus D is 4x minus 4x is 0, and minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. But according to the rule that cosine minus x equals to cosine x, we get that cosine minus 45 degrees equals to cosine 45 degrees. And then we'll treat this expression 2 cosine 2x plus 45 degrees. Here A equals to 2x and B equals to 45 degrees, and cosine A plus B equals to cosine A cosine B. That is to say, it equals to cosine A is 2x times cosine B is 45 degrees minus sinus A is sinus 2x times sine 45 degrees. So here we will divide this equation number 1, by 2 times cosine 45 degrees. Here 2 cosine 45 degrees will get cancelled. Here also 2 cosine 45 degrees will get cancelled. And here we know that sinus 45 degrees equals to cosine 45 degrees. So here we have 2 sine 45 degrees will get cancelled, and what is left after we cancel 2 cosine 45 degrees. What is left? It is actually, for question number 1, we got that cosine 2x equals to sine 2x cosine 4x equals to cosine 2x minus sine 2x. So here we will add sine 2x to this equation number 1, and we will get that sine 2x, and we will subtract also cosine 4x equals to cosine 2x minus cosine 4x, and we know that sine 2x is equal to 2 sine x cosine x, so I write it down, 2 sine x cosine x, and it equals to cosine 2x minus cosine 4x, actually cosine 2x minus cosine 4x, it is similar to the trigonometric identity that cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2. So we will use this trigonometric identity in order to simplify the expression cosine 2x minus cosine 4x, and we will get that 2 sine x cosine x equals, here actually C equals to 2x and D equals to 4x. So cosine C minus cosine D equals to 2 sine D plus C over 2. D is 2x, for C is 2x, D is 4x, so 2x plus 4x is 6x, and 6x over 2 is 3x, times the sine D minus C over 2. D minus C is 2x over 4, D is 4x, C is 2x, so D minus C is 4x minus 2x is 2x, and 2x over 2 is x. So here we will divide this equation by 2 sine x, and here, so here 2 sine x will get cancelled, and here also 2 sine x will get cancelled, and we will get that cosine x equals to sine 3x, and we will use the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine x equals to sine 90 degrees minus x, and it equals to sine 3x, So we got that sine 90 degrees minus x equals to sine 3x. That is to say 90 degrees minus x equals to 3x. Here we will add to this equation number 1 x, and we will get that 90 degrees equals to 4x, because 3x plus x is 4x. Here we will divide equation number 1 by 4, and we will get that x equals to 90 degrees over 4. 90 degrees over 4 is 22.5 degrees. So we found out that x equals to 22.5 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of angle x according to the second method. In the second method, we will define angle QPS as alpha. We will define angle SPR as beta. We have already found out that this angle PSR equals to 135 degrees. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle PQS, the sum of the angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. I'll repeat again. In triangle PQS, the sum of the angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. Here we will subtract 3x and also 45 degrees from this equation number 1, and we will get that alpha equals to 180 degrees minus 45 degrees is 135 degrees. So we only subtract 145 degrees from this equation, and we will get that alpha plus 3x equals to 135 degrees. Likewise, we will focus on triangle PSR. On triangle PSR, the sum of the angles must be equal to 180 degrees. So which angles we have in triangle PSR? The angles that we have in triangle PSR is actually beta plus 135 degrees plus x must be equal to 180 degrees. I will repeat again. In triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus 135 degrees plus angle x must be equal to 180 degrees. Here we will subtract 135 degrees from this equation number 2, and we will get that angle beta equals to 180 degrees minus 135 degrees is 45 degrees, and we also subtracted x, so it equals to beta equals to 45 degrees minus x. Actually, here I will add x to this equation, and we will get that beta plus x equals to 45 degrees according to equation number 2. Here we will multiply this equation number 2 by 3, and we will get that 3 beta plus 3x equals to 135 degrees. Here actually we have equation number 2 that states that 3 beta plus 3x equals to 135 degrees, and we have equation number 1 that states that 100 plus 3x equals to alpha plus 3x equals to 135 degrees. So we can write down the equation number 3 that states that equation number 1 equals to equation number 2. Actually, this side of equation number 1, that is alpha plus 3x equals to 135 degrees. And this side of equation number 1, that is 3 beta plus 3x also equals to 135 degrees. So that is to say, those two sides are equal to each other. Here we will subtract 3x from this equation, equation number 3, and we will get that alpha equals to 3 beta. So according to equation number 3, alpha equals to 3 beta. Here we will do a construction from point Q. We will draw a straight line to PR in such a way that the angle that will be created will be equal to x. So actually, this angle equals to x. It equals to x because we built it in such a way that it will be equal to x. Okay? So we know that angle PQR equals to 3x, and this angle equals to x. So the rest must be equal to 2x. Okay, so angle PQ and here we'll define this point as point M. So actually angle PQM equals to M, to 2x. Angle PQM equals to 2x, and angle MQR equals to x. So in triangle PQR we have two angles. In triangle MQR we have two angles that are both of them are equal to x. Therefore triangle MQR is an isosceles triangle. Because it has two angles that are equal to each other, they are both equal to x degrees. And the base of the isosceles triangle, triangle MQR, is QR. We'll join points M and S together by a straight line. Actually, line segment MS bisects the base QR of the isosceles triangle MQR into two equal parts. That is to say, QS equals to SR according to what is given us in the question. Therefore, actually, MS is the median of the isosceles triangle MQ because it bisects the base QR into two equal parts. That is to say, QS equals to SR. But according to rule number 3, the median to the base, it is also perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. In the next step, I will present to you a new rule, rule number 3. According to rule number 3, actually rule number 4, according to rule number 4, an exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it. I'll read rule number 4 again. According to rule number 4, an exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC, and the interior angles of triangle ABC are, this angle is alpha, this angle equals to beta, and this angle equals to gamma. So the three interior angles of triangle ABC are alpha, beta, and gamma. And also triangle ABC has this exterior angle, actually angle SAB. This angle is an exterior angle of triangle ABC. Why it is an exterior angle? Because it is located outside the triangle ABC. Therefore, it is defined as an exterior angle of triangle ABC. And according to rule number 4, an exterior angle of a triangle, that is to say angle SAB, is equal to the sum of the angles that are not adjacent to it. The only angle that is adjacent to this angle SAB is actually angle gamma, and the two other angles that are not adjacent to angle SAB are alpha and beta. And according to rule number 4, the value of the exterior angle SAB is equal to the sum of the angles that are not adjacent to it. That is to say, it equals to alpha plus beta, because alpha plus beta are the two angles that are not adjacent to the exterior angle, angle SAB. Because angle gamma is adjacent to angle SAB, and angle alpha and beta are not adjacent to angle SAB, therefore the value of the exterior angle SAB according to rule number 4 is alpha plus beta. And you actually can implement rule number 4 in our drawing, because in our drawing we have the isosceles triangle QMR is an isosceles triangle because it has two angles that are equal to each other, they are both equal to x, and angle QMR, this angle is defined as an exterior angle of triangle QMR because it is located outside triangle QMR, so it is the exterior angle of triangle QMR. And according to rule number 4, the exterior angle QMP, this angle is equal to the sum of the angles that are not adjacent to it. The two angles that are not adjacent to it are those two angles. So it equals to x plus x. Because the sum of those two angles that are not adjacent to it are x plus x, that is to say, it equals to 2x. So angle PMQ equals to 2x. Therefore, triangle PMQ is an isosceles triangle because it has two angles that are equal to each other. They are both equal to 2x. And we have the rule that in front of equal angles in a triangle, there are equal sides. In front of those two equal angles that are 2x, that are equal to 2x, there are equal sides. The two sides that are in front of those two angles are PQ and PM, and according to the rule it is stated, they are equal to each other. That is to say, PQ equals to PM. So we found out that PQ equals to PM. I write it down, PQ equals to PM. Okay. In the next step, I will draw perpendicular from point P to QM, and then I will extend it until it touches QS. So from point P we'll draw perpendicular to QM. So this angle is a right angle, it equals to 90 degrees. And this angle, it is also a right angle, that is to say it equals to 90 degrees. Then we will extend the perpendicular from point P until it touches QS, and we will define the touching point between the perpendicular from point P to QS as point N. We will define the touching point from point P, from the perpendicular. We will define the touching point of the perpendicular from point P to QM as point L, and we will focus on triangle PQL and triangle PLM. Triangle PQL and triangle PLM. We will focus on those two triangles. First of all, we know that those two angles are equal to each other, they are both equal to 2x. So angle PQL in triangle PQL is equal to angle PML and they are both equal to 2x. I repeat again, angle PQL equals to angle PML and they are both equal to 2x. We also have those two angles that are equal to each other. That is to say, they are equal to 90 degrees. So angle PLQ, this angle, is equal to this angle, angle PLM, and they are both equal to 90 degrees. I repeat again, angle PLQ equals to angle PLM and they are both equal to 90 degrees. Those two angles, they are also equal to each other according to third angle theorem. So angle QPL is equal to angle MPL and they are equal to each other according to third angle theorem. I repeat again, angle QPL equals to angle MPL and they are equal to each other according to third-angle theorem. So what is third-angle theorem? Third-angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Why? Because it is complementary to 180 degrees. Okay? And we found out that those two angles in triangle PLQ are equal to those two angles in triangle to PLM. Therefore, we have two pairs of angles that are congruent. Therefore, the third pair of angles, those are defined as the third pair of angles, must also congruent. That is to say, they are equal to each other. So, if we define angle QPL as theta, angle QPL equals to theta, then angle MPL, this angle will be also equal to theta. So from this drawing, you can see that theta plus theta equals to alpha plus beta. Again, from the drawing, you can see that theta plus theta equals to alpha plus beta. That is to say 2 theta, theta plus theta is 2 theta equals to alpha plus beta. But we have already found out that alpha equals to 3 beta, so we can substitute alpha in this equation by 3 beta. We will do it and we will get that 2 theta equals to alpha is 3 beta plus beta. So 2 theta equals to 3 beta plus beta, that is to say it equals to 4 beta. Here we will divide this equation by 2 and we will get that theta equals to 2 beta. So we found out that theta equals to 2 beta. So we can write here that theta equals to 2 beta. And here also we write down that theta equals to 2 beta. So angle LPM equals to 2 beta and angle SPM equals to beta. So if we subtract angle LPM from angle SPM, we will get the value of angle NPS. So actually angle LPM, that is 2 beta, minus angle SPM, that is beta, will be equal to this angle, that is actually 2 beta minus beta equals 2 beta. So we found out that this angle equals to beta. Okay? And here we already found out that angle MSN is equal to 90 degrees and angle PSN equals to 45 degrees. So 90 degrees minus 45 degrees, it will be equal to angle MSP. So angle MSP equals to 90 degrees minus 45 degrees, that is to say it equals to 45 degrees. And in the next step, we will prove that those two triangles can go into each other. So I will copy them and we will prove that they can go into each other. So we will prove that triangle PNS is congruent to triangle PMS. So triangle PNS So we actually prove that triangle PNS, the green triangle PNS, is congruent to the white triangle PMS. Okay, I write it down. The green triangle PNS is congruent to the white triangle PMS. So why they congruent to each other? First of all, we have two angles that are equal to each other. They are both equal to beta, so angle NPS in the green triangle is equal to angle MPS on the white triangle, and they are both equal to beta. So you can see here in the drawing. We have PS is a common side that belongs to both triangles, so we can write down that PS equals to PS is a common side that belongs to both triangles. And we also have those two angles that are equal to each other. They are both equal to 45 degrees. So angle NSP in the green triangle is equal to angle PSM in the white triangle, and they are both equal to 45 degrees. So we actually proved that the green triangle PNS is congruent to the white triangle PSM according to angle side angle rule. I'll repeat again. We actually proved that the green triangle PNS congruent to the white triangle PSM according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles and the side that included between those two angles in one triangle congruent to two angles and the side that included in another triangle, then you prove that those two triangles congruent to each other according to angle side angle rule. And we actually proved that those two angles and the side that included between them, that is to say PS in the white triangle, congruent to those two angles and the side that included between them, that is to say side PS in the green triangle. Therefore we proved that those two triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that NS equals to MS. NS equals to MS. Okay? We will join points N and M together by a straight line. And I will draw triangle MLS again in the new page. So here we will have triangle MNS. Here triangle MNS. So this is triangle MNS. It is a right triangle. This angle equals to 90 degrees, and we know that NS equals to MS. front of equal angles, they are equal sides. In front of equal angles, in front of equal sides, there are equal angles. So the triangle, so NS equals to MS. So in front of those two sides that are equal to each other, they are equal angles. So those two angles must be equal to each other. So if this angle is y, then this angle will be also equal to y. But we know that the sum of the angles in any triangle is equal to 180 degrees. So this angle is the right angle, it equals to 90 degrees. So the other two angles must be equal to 90 degrees in order to complete the sum of the angles in this triangle to 180 degrees. That is to say, y plus y equals to 90 degrees. Y plus y equals to 90 degrees. That is to say, 2y equals to 90 degrees. We will divide this equation by 2 and we will get that angle y equals to 45 degrees. So we found out that those two angles are equal to 45 degrees. So we substitute angle y by 45 degrees. So this angle equals to 45 degrees and this angle also equals to 45 degrees. Okay? So we can here now forming we will join points and M together by a straight line. We found that angle MNS equals to 45 degrees, and also this angle equals to angle SMN equals to 45 degrees. Why? Because NS equals to MS. Okay? In the next step, so we can write here that NS equals to MS. In the next step, we will prove that triangle PQN is congruent to triangle PNM. I will draw those triangles together again in a new page and we will prove that they can congruent to each other. Okay, we have triangle PQN, triangle PQN. And triangle PNM or PMN. So we will prove that the green triangle PQN is congruent to the white triangle PNM. I will write down the two triangles, triangle PQN is congruent. We will prove that triangle PQN, the green triangle, is congruent to triangle PNM. So why they congruent to each other? First of all, we have already found out that PQ equals to PM. Here, PQ equals to PM. Those two angles are equal to each other. They are both equal to 2 beta. So angle QPN in the green triangle equals to angle NPQ in the y triangle equals to angle NPM in the y triangle, and they are both equal to 2 beta. As you can see from the drawing, angle QPN in the green triangle equals to angle NPM in the y triangle, then they are both equal to 2 beta. And we have also a common side. PN is a common side, it belongs to both triangles. So we can write down that PN equals to PN as a common side that belongs to both triangles. So we actually proved that the green triangle PQN, congruent to the white triangle PNM, according to side angle side rule. I'll repeat again. We proved that the green triangle PQN congruent to the white triangle PNM according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove the two sides and the angle between them in one triangle congruent to two sides and the angle between them in another triangle, then you proved that those two triangles congruent to each other according to side angle side rule. And we actually proved that those two sides and the angle between them, that is to say 2 beta in the y triangle, congruent to those two sides and the angle between them, that is to say 2 beta in the green triangle. Therefore we proved that the green triangle is congruent to the y triangle according to side angle side rule. And from the fact that those two triangles congruent to each other, we will conclude that Qn equals to Mn. So Qn equals to Mn. So I will join points Q and M together by a straight line, and I will draw triangle Q and M in a new page. So we have triangle QMN. We already found out that Qn equals to Mn. I repeat again. This is triangle Q and M. And in triangle Q and M, we know that Qn equals to Qn equals to Nm. And we know that, so actually angle MQN equals to X. This angle MQN equals to X. We built it like that. And we know that Qn equals to Nm. And according to the rule that in front of equal sides in the triangle there are equal angles, we will get that in front of those two equal sides there are equal angles. That is to say, those two angles must be equal to each other because they are located in front of the equal sides Qn and Nm. So if those two angles are equal to each other and this angle is x, then this angle must be also equal to x. So we found out that those two angles, they are both equal to x. And here we have point S. So in triangle NMQ, the value of the exterior angle MNS, angle MNS, according to rule number 4, it will be equal to the sum of the two angles that are not adjacent to this exterior angle. And the two angles that are not adjacent to this exterior angle, angle MNS, are those two angles. And the sum of those two angles is actually x plus x. That is to say, the exterior of angle MNS will be equal to x plus x. That is to say, it equals to 2x. So we found out that angle MNS equals to 2x according to rule number 4. And we have already found out that angle MNS, this angle MNS equals to 45 degrees. So you can see from the drawing. So angle MNS equals to 45 degrees from the other side. From this equation, we will get that 2x equals to 45 degrees. 2x equals to 45 degrees. We will divide this equation by 2, and we will get that x equals to 45 degrees over 2, that is to say x equals to 22.5 degrees. So we found out that the value of angle x according to the second method is 22.5 degrees, exactly as we found in the first method. We finished with the second method. In the next step, I will summarize the lecture. Actually, we wanted to find out the value of angle x, and we found out the value of angle x in two different methods. In the first method, I repeat on the equation, we have here triangle PQR, QS equals to SR, angle PSR equals to 45 degrees, this angle equals to 3x, this angle equals to x, and we want to find out the value of angle x. We defined this angle as alpha, this angle as beta, and this angle equals to y. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line QR at point S, the sum of the angles must be equal to 180 degrees. That is to say 45 degrees plus angle Y equals to 180 degrees. Here, 45 degrees plus angle Y must be equal to 180 degrees. We subtracted 45 degrees from this equation, and we got that angle Y equals to 135 degrees. So we found out that angle Y equals to 135 degrees, so we substituted Y by 135 degrees. Then I presented to you a new rule, the law of sines. In any triangle, if the length of this side is A, the length of this side is C, and the length of this side is B, and this angle is A, this angle is B, and this angle is C, then according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Okay, from this formula we will conclude that A over sine A equals to B over sine B. We multiplied this equation by sine A, and then we divide it by B, and we got that A over B equals to sine A over sine B. What does this formula mean? It means that the ratio between the side lengths of any triangle is equal to the ratio between the opposite angles. Okay? Then we focused on our triangle, on our drawing. We know that here PS over QS will be equal to PS over SR. And then PS over QS equals to PS over SR. Why? Because QS is equal to SR according to what is given as the equation. QS equals to SR. Therefore, equation number 1 is true. But according to the rule that I presented to you, the ratio between the length sides of any triangle equals to the ratio between the opposite angles. So if we focus on triangle PQS, the value of PS over QS, the value of PS over QS, according to the rule that I mentioned, it must be equal to sinus 3x over sinus alpha. Okay, PS over QS equals to sinus 3x over sinus alpha. And if you focus on triangle PSR, then the ratio of PS over SR, the ratio of PS over SR must be equal to sine X over sine beta, according to the rule that I mentioned. So PS over SR equals to sine X over sine beta. So we got the equation number 1, that sine 3x over sine alpha equals to sine X over sine beta. We focus on triangle PQS. On triangle PQS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. We subtracted 3x and also 45 degrees from this equation number 2, and we got that angle alpha equals to 180 degrees minus 3x plus 45 degrees. Likewise, we focused on triangle PSR. The sum of the angles on triangle PSR must be equal to 180 degrees. That is to say, beta plus 125 degrees plus x equals to 180 degrees. Then we subtracted 135 degrees and also x from this equation number 3, and we got that angle beta equals to 45 degrees minus x. So we can substitute alpha and beta in this equation number 1, by the values that we found for alpha and beta in equation number 2 and equation number 3. We did it, and we got that sine 3x over sine alpha is 180 degrees minus 3x plus 45 degrees. It equals to sine x over sine beta, and beta is 45 degrees minus x. Okay, then we have the trigonometric identity that states that sine 180 degrees minus theta equals to sine theta. According to this trigonometric identity, we will get that sine 180 degrees minus 3x plus 45 degrees equals to sine 3x plus 45 degrees. So we wrote again equation number 1 after we did the change, and we got that sine 3x over sine 3x plus 45 degrees equals to sine 3x over sine 45 degrees minus x. Then we cross multiply this equation number 1, and we got this expression. Then we multiply this expression by 2, and we got this expression. We simplify this equation number 1, by the trigonometric identity that states that 2 sine A sine B equals to cosine A minus B minus cosine A plus B. We focus on this expression. Here you can see that A equals to 3x, B equals to 45 degrees minus x. So, and according to this trigonometric identity, this expression is equal to cosine A minus B. So cosine A minus B, A is 3x and B is 45 degrees minus x. It equals to 3x minus x is 4x, and here 0 minus 45 degrees is 45 degrees. So in conclusion, we got here cosinus 4x minus 45 degrees, and we also have to subtract minus cosinus A plus B. Minus cosinus A is 3x and B is 45 degrees minus x, so 3x plus minus x is 2x, and here 0, here we have A minus B, so it is 0 minus 45 degrees. It is actually 0 minus 45, so it is actually 3x minus this expression, and here we have 45 degrees, so we didn't touch at 45 degrees, so 45 degrees remains 45 degrees. So because A minus B is 3x minus this expression, So it will be equal to minus 3x minus and minus is plus, so it is 2x plus 45 degrees. Okay, and then we have this expression. Then we treated this side of equation number 1. Here a equals to x, b equals to 3x minus 45 degrees, and cosine a minus b is actually 3x minus x, 3x minus x is 4x, and we have here 45 degrees, so we left with 45 degrees, and here we have this expression. It equals to cosine 45 degrees, cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, and it equals to 2x plus 45 degrees. And in order to simplify this expression, we use the trigonometric identity that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2. And in order to simplify the expression 2 cosine 2x plus 45 degrees, we use the trigonometric identity that cosine a plus b equals to cosine a times cosine b minus sine a times sine b. And here c is 4x minus 45 degrees and d is 4x plus 45 degrees. So we have cosine c plus cosine d equals to 2 cosine c plus d over 2. Here 2 cosine c plus d, here c plus d is 4x plus 4x is 8x, and 8x over 2 is 4x, and minus 45 degrees plus 45 degrees is 0. And we have also here times cosine c minus d over 2. So c minus d is 4x minus 4x is 0, and minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees, but because of the fact that cosine minus x equals to cosine x, we get that cosine minus 45 degrees equals to cosine 45 degrees. Here we divided this equation number 1, by 2 cosine 45 degrees. Okay, and what is left after we divided the equation number 1 by 2 cosine 45 degrees? What is left? It is actually cosine 4x equals to cosine 2x minus sine 2x. And here we added to this equation sine 2x, and then we subtracted cosine 4x. In conclusion, we got that sine 2x equals to cosine 2x minus cosine 4x. We know that sine 2x equals to 2 sine x cosine x, so, and it equals to cosine 2x minus cosine 4x. We simplify this expression by the trigonometric identity that states that cosine c minus cosine d equals to 2 sine d plus d plus c over 2 times sine d minus c over 2. Here c equals to 2x and d equals to 4x. As you can see here, so d plus c over 2 is 2x plus 4x is 6x, and 6x over 2 is 3x, so we got 2 sine 3x, and then we have times sine d minus c over 2. D minus c is 4x minus 2x is 2x, and 2x over 2 is x. So in conclusion, we got that 2 sine x cosine x equals to 2 sine 3x times sine x. We divided this equation number 1 by sine x, and we got that cosine x equals to sine 3x. It means that we use the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha. So according to this trigonometric identity, cosine x will be equal to sine 90 degrees minus x. And so we got that sine 90 degrees minus x equals to sine 3x. That is to say 90 degrees minus x equals to 3x. We added x to this equation number 1, and we got that 90 degrees equals to 4x. We divided equation number 1 by 4, and we got that x equals to 90 degrees over 4. That is to say x equals to 22.5 degrees. So we found out that angle x equals to 22.5 degrees. So we finished with the second method, and then I presented to you how to find out the value of angle x according to the second method. According to the second method, here we define this angle as alpha, this angle as beta, and this angle equals to 135 degrees. And we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say the sum of the angles in triangle PSQ equals to 180 degrees. That is to say alpha plus 3x plus 45 degrees equals to 180 degrees. Then we subtracted 45 degrees from this equation, and we got that alpha plus 3x equals to 135 degrees. Then we focus on triangle PSR. And triangle PSR, the sum of the angles is equal to 180 degrees. That is to say beta plus 135 degrees plus x equals to 180 degrees. We subtracted 135 degrees from this equation, and we got that beta plus x equals to 45 degrees, because 180 degrees minus 135 degrees equals to 45 degrees. So in conclusion, we got that beta plus x equals to 45 degrees. We multiply this equation number 2 by 3, and we got that 3 beta plus 3x equals to 135 degrees. So we can write down the equation number 3 that states that alpha plus x, according to equation number 1, that is 135 degrees, equals to 3 beta plus 3x, that is also 135 degrees according to equation number 2. So this is equation number 3. We subtracted 3x from equation number 3, and we found out that alpha equals to 3 beta. So alpha equals to 3 beta according to equation number 3. We did here a construction from point Q. We drew a straight line to PR in such a way that this angle will be equal to x. So this angle equals to x, and this angle also equals to x. So therefore, triangle QMR is an isosceles triangle because it has two angles that are equal to each other. They are both equal to x, and the base of triangle QMR is QR. We join points M and S together by a straight line. MS is the median to the base of the isosceles triangle QMR, because it bisects the base. That is to say, QS equals to SR, but it is not only bisects the base, but it's also perpendicular to the base. That is to say, this angle equals to 90 degrees, this angle also equals to 90 degrees, according to rule number 3, that the median to the base in an isosceles triangle is perpendicular to the base. This is an isosceles triangle QMR is an isosceles triangle, and the base is QR, so the median to the base, that is MS, is perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? And then I presented to you rule number 3. According to rule number 3, an exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have the triangle ABC has 3 interior angles, The three interior angles are alpha, beta, and gamma, and the exterior angle is angle SAB. And the value of the exterior angle, according to rule number 4, it equals to the sum of the angles that are not adjacent to it. Angle gamma is adjacent to angle SAB, and the two other angles that are not adjacent to angle SAB are alpha and beta, and according to rule number 4, the value of angle SAB is the sum of the two angles that are not adjacent to it, that is to say it equals to alpha plus beta. So according to rule number 4, the exterior angle SAB of triangle ABC equals to alpha plus beta. We can implement rule number 4 in our drawing, because in our drawing we have associated triangle QMR, and the exterior angle of triangle QMR is angle PMQ, and according to rule number 4, the value of the exterior angle PMQ, it will be equal to the sum of the two angles that are not adjacent to it. The only two angles that are not adjacent to it are those two angles. Therefore, the value of the exterior angle PMQ is the sum of the two angles that are not adjacent to it, that is to say it equals to x plus x. So we found out that angle PMQ is equal to 2x. But this angle also equals to 2x, therefore this is an isosceles triangle. In triangle PQM, that is an isosceles triangle, we have the rule that in front of equal angles there are equal sides. That is to say, PQ and PM are in front of equal angles that are equal to each other. Therefore, PQ equals to PM. PQ equals to PM. Okay. Then we drew perpendicular from point P to QM, so this angle equals to 90 degrees and this angle equals to 90 degrees. Then we extended the perpendicular until it touches QS at point N. Then we focused on those two triangles. In those two triangles, triangle PQL, angle PQL equals to angle PML equals to 2x. Those two angles, they are both equal to each other, they are both equal to 2x. Those two angles, they are also equal to each other, they are equal to 90 degrees. Angle PLQ equals to angle PLM equals to 90 degrees. And those two angles, they are equal to each other according to third angle theorem. That is to say, angle QPL equals to angle MPL according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle can go into two angles in another triangle, then the third pair of angles must also can go in, because it completes the sum of the angles to 180 degrees. And we actually proved that those two angles in triangle PLQ can go into those two angles in triangle PLM. Therefore, the third pair of angles must also can go in, because it completes the sum of the angles to 180 degrees. That is to say, angle QPL equals to angle MPL. So if we define angle QPL as theta, then angle LPM will be also equal to theta. Okay? And from the drawing you can see that theta plus theta equals to alpha plus beta. Theta plus theta equals to alpha plus beta. That is to say 2 theta equals to alpha plus beta. But we have already found out that alpha equals to 3 beta according to equation number 3. So we can substitute alpha by 3 beta. We did it and we got that 2 theta equals to alpha, that is 3 beta plus beta. That is to say 2 theta equals to 3 beta plus beta is 4 beta. 2 theta equals to 4 beta, so we divided this equation by 2 and we got that theta equals to 2 beta. So here we can write down that 2 theta equals to 2 beta, and here also theta equals to 2 beta. Then, because of the fact that the angle that I marked in the red color, it equals to 2 beta, and angle SPN equals to beta, then you can see from the drawing that the angle that I marked in the red color minus angle SPM must be equal to this angle. So the angle in the red color is equal to 2 beta. Minus this angle that is beta equals 2 beta. So angle NPS equals 2 beta. And here also we have angle that is right angle, it equals to 90 degrees, and this angle equals to 45 degrees. So 90 degrees minus this angle that is 45 degrees must be equal to this angle. So this angle equals to 90 degrees minus 45 degrees is 45 degrees. Then we proved that triangle P and S is congruent to triangle PMS. I do to again triangle P and S is the green triangle is congruent to triangle PMS. Why they congruent to each other? First of all, we have those two angles that are equal to each other. They are both equal to theta. So angle NPS equals to angle NPS equals to beta. We have a common side. PS is a common side. It belongs to both triangles. So PS equals to PS. And those two angles, they are both equal to each other, they are both equal to 45 degrees. So angle NSP equals to angle PSM equals to 45 degrees. So we proved that the green triangle can run to the white triangle according to side angle rule. And from that fact we will conclude that MS equals to SN. So I join together points M and N by a straight line, and I draw triangle M and S in a new page. Here we have triangle M and S. We know that this is a right angle, and we also know that MS equals to SN. Those two sides, they are equal to each other, and we know that in front of equal sides in the triangle there are equal angles. That is to say, those two angles that are in front of the equal sides must be also equal to each other. So if this angle is y, this angle is also y. So y plus y must be equal to 90 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So 2y plus y is 2y, 2y equals to 90 degrees. We divided this equation by 2 and we got that angle y equals to 45 degrees. So this angle equals to 45 degrees and this angle also equals to 45 degrees. So we found out that angle MNS equals to 45 degrees. So we can write here that angle MNS equals to 45 degrees. Okay? And we also found out that SNS equals to SM. And then we actually proved the triangle PQN can go into triangle PNM. Triangle PQN can go into, the green triangle can go into triangle PNM. Why they can go into each other? Because PQ equals to PM. PQ equals to PM. We have already found out that PQ equals to PM. Those two angles, they are both equal to each other, they are both equal to 2 beta. So angle NPQ equals to angle NPM equals to 2 beta. Okay, and we have a common side PN equals to itself. It's a common side that belongs to both triangles. So we proved the triangle PQN equals to triangle PNM according to side angle side rule. So what is side angle side rule? If you prove that two sides and the angle between them in one triangle can go into two sides and the angle between them in another triangle, then you proved that those two triangles can go into each other according to side angle side rule. And we proved that those two sides and the angle between them, that is to say 2 beta, in the white triangle can go into those two sides and the angle between them, that is to say 2 beta, in the green triangle. Therefore we proved that those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that QN equals to MN. QN equals to MN. So I draw triangle QMN again in a new page. And here we have triangle QMN. And we know that QN equals to MN. In triangle QMN, QM equals to MN. And in front of equal sides in the triangle, there are equal angles. We know that this angle equals to x. So this angle must be also equal to x because those two angles, they are equal to each other. So if this angle is x, this angle must be also equal to x. And according to rule number 4, the exterior angle MNS of triangle QMN equals to the sum of the angles that are not adjacent to it. That is to say, it equals to x plus x. So we found out that angle MNS equals to 2x according to rule number 4. But from the other side, we have already found out that angle MNS equals to 45 degrees. So you can see from the drawing, angle MNS equals to 45 degrees. So we have the equation that states that angle MNS equals to 45 degrees, and it also equals to 2x. So from this equation, we will get that 2x equals to 45 degrees. We divided this equation by 2 and we got that x equals to 45 degrees over 2, that is to say x equals to 22.5 degrees. So we found out that angle x equals to 22.5 degrees, and we got the same result also in the first method. So that's all. Thank you very much.